Hey guys, I'm Shreyas, and today we're in the 11th day of the LeetCoding challenge of July month. And the question for today is find median from the data stream. So this question is similar to finding the median of an array, which we already know. But the twist in this question is that we have a data stream and the input array is not given to us at once. So it's like a continuous data processing, and they may ask us to find the median at any point of time, and we may have different number of elements at different time intervals. So there is a question, and the input, the sample test cases are easy to understand. For example, they are asking in the fourth order is find median. So at that time we have 1 and 2 with us, and the median of 1 and 2 is 1.5. So and at the sixth instruction is also to find median, but at that point we have three elements with us, that is 1, 2 and 3, and hence the median of them will be 2. So that is the thing. The only difference is it's continuous data processing. So we can follow the brute force approach, which we used to follow if the input array was given at once, but each time we have to keep sorting the input array whenever we add new elements, and the time complexity would be like O of n in that case. For example, I had a submission based on that approach only. I have taken a multiset. Multiset basically stores duplicates as well, while set doesn't store duplicates. And so whenever they ask us to find median, so we just go to the middle element and then print the answer. Depending on odd or even, it depends, like whether we have to take the average of the middle two elements or only the one middle element. Depends on the depends on whether the array size is odd or even. So that is the approach, but this thing takes O of n time in that case, and it's not a great approach. Yeah. So in order to optimize this, we can take the help of two heaps or two sets instead of one set only. So like in general terms, instead of set we can say heaps, because it's a generic term which can be used in all languages, not only in C++. So we have to take the help of two heaps. One is the max heap and one is the min heap. So previously we saw that the finding the median, we had to go to the middle element of the heap and then find out. So over here, to overcome that shortcoming, we take the help of two heaps. One is the max heap and one is the min heap, and what they represent is, when we combine max heap and min heap together, they represent one sorted array. And the so we are splitting the array into two equal halves. So the max heap will represent the first half of the array and the min heap the second half. And the idea is that to keep the middle element at the top. So over here the max element and over here the min element. So the max heap will store the maximum element at the topmost position, and the min heap will store the minimum element at the topmost position. So this is like in ascending order and this like decreasing order. So when we combine these two, it will be a single sorted array. And now we can obtain the median in O of one time, because we have the middle elements in the topmost position of the heaps. So that is the intuition of using two heaps, and like more things will be clear as we go through the code. So first the max heap and the min heap. So max heap is the first part of the array and min heap the second part. And since the min heap should store the value in decreasing order, we need to give this vector int and greater int as well to store the in decreasing order, and to store in ascending order, in the sense the topmost element will be the least and the last element will be the greater. So and yeah, so whenever they ask us to add a number, if the max heap is empty, then we push it to the max heap only, or if the number is less than the topmost element of the max heap, again we push it to the max heap, because the max heap will store the order, will represent the first part of the array. So whatever is less than the topmost part of the heap should go to the first part of the array only. otherwise we push it to the min heap, which is the second part of the array. Now, as we discussed earlier, we have to keep the sizes of the heaps as close as possible. So if the difference of the sizes exceeds, like, is greater than or equal to 2, then we shift the topmost element from the heap which has greater size to the heap which has lesser size, so that the maximum difference between the heap sizes is at most 1 only, not greater than 1, so that pushing and popping operations happen in this part of the code. And next is the find median. So if they ask us to find the median, and if the second part of the array is empty, then we just return the first topmost element of the max heap. That means the array has only one element till now. And if the sizes of the heaps are equal, that means till now we have processed even number of elements, so the sizes of them are equal, and so we have to return the average of the topmost values. Else, if one of the heaps has a greater size than the other, then we have to return the element which has that extra number, so that would be the middle value of the data processed till now. So using this approach, the operations get simplified to a great extent, and the find median operation can be like processed in O of 1 time, and the add number would be processed in O of log n time. So initially it was O of log n and O of n. Now it's O of log n and O of 1. So this is how we optimize the approach, and that's it for the video, guys. Thanks for watching.